Hi everyone, and welcome to my presentation for Lab 4, Physics 2211. The purpose of this lab was to compare the energy of the predicted motion and observed motion of the mass for the model prediction and your analyzed data, and plot the energy changes computed in the model, such as kinetic energy, gravitational potential energy, the change in spring potential energy, and the change in total energy. The results showed us that delta E equals 0 because this is a closed system and the model overpredicted motion of the mass spring system as compared to the observational data. The physics principles involved in this lab were Newton's second law, spring force, gravitational force, and the work energy principle. Newton's second law is rearranged to find the final velocity and the final position of the system, and the net force was calculated by adding up all the forces acting on the system. These forces were the gravitational force and the spring force. Spring force was calculated using Hooke's law, and the gravitational force was found by negative mg since the system was close to the Earth. Since this is a closed system, the change in energy should be 0. The change in energy is then equal to the change in kinetic energy and the change in potential energy. Potential energy is made up of the gravitational energy, which is found through mgy, and the potential energy of the spring, which is 1/2 ks squared. The kinetic energy is then found by 1/2 m delta v squared. The setup was as follows. All the initialization values were given in the past lectures. We found the relaxed spring length by setting the magnitude of the gravitational force to the magnitude of the spring force. We also oriented our coordinate axis to the positive x direction to be the right direction and the positive y direction to be the up direction. Here is a video of my tracker data analysis. You can see in the top right corner the position data being plotted as a function of time. The values at the bottom of the chart were exported as a CSV file to be used in the Python code. The initialization of the code included the mass of the ball in the original position vector. The spring stiffness and the relaxed length of the spring were inserted from the values calculated earlier. The equations for L, L hat, and S were updated to reflect the correct calculations. The system's energies were computed by putting the correct formulas into the Python code. In the first loop, Newton's second law was used to update the velocity and position of the system. And the spring was also updated by putting in the correct equations for L, L hat, and S. To calculate the various energies, we put in the correct formula for each of the energies, such as kinetic energy, gravitational potential energy, and spring potential energy into the code. Here is the result from the Python code. In this video, the kinetic energy is represented by the blue line, the gravitational potential energy is red, and the spring potential energy is green, and the total energy is in orange. This is the result of the Python code for the position versus time graph for the computer model. The prediction model is in blue, and the observed data is in red. The results of this lab demonstrate the change in energy of the system to be 0 because it was closed. This was visualized by the orange line in the results of the Python code. As kinetic energy increases, potential energy decreases and vice versa, so they cancel out. The model and the observed position start out the same, but as time progresses, they become out of sync. This is because for every 1 point from the observed data, there are many more points for the model, and the model does not take into the accounts the effects of air resistance / drag. This results in the model overpredicting the motion of the spring. To answer the first question, yes, the energy principle is satisfied. The sum of all energies acting on the system should be 0. This is a closed system, so no energy should be gained or lost in the system. The graph from the Python code shows this to us because the orange line, which represents the total energy, remains at 0 during the duration of the code. To answer the second question, the time period would be calculated using the formula below. T equals 2 pi square root of m over k. But in this case, we use the position data points for the x and y direction to determine the period. The period for the x position data was 0.71, and for the y position, it was 0.76. These values are pretty close, but the vertical y value depends on the spring constant, and the horizontal x value depends on the force of gravity. Thank you for watching this video.